Let's do one example of a molecule in which we can assign priorities to group. It's going to be in wedge and dash. We're going to go sawhorse, and then we're going to do Newman and Fisher lastly. So all of the configurations. So I'm going to start drawing way to the side so that hoping we can have room for everything. So here I have OH. And I'm looking at my handout, as you can see, I need to go a little bit to the right because it's not showing on the screen, that's fine. OH, and here I have a CH3, and then at this carbon, I am going to draw H, bromine, and at the other carbon, I have, this wedge is a chlorine, and I have a hydrogen here. All right, so that's my wedge and dash. My chlorine is not showing. I'm gonna have to make this shorter so that you can see that I have a chlorine here. Let's see. Can redraw that. That is a chlorine. That's not visible. Sorry about that. I need to keep moving. So those are the things. This is tricky. Okay, let's move on a little bit more to the right. I just wanted to have room for everything because I want to do different projections here. So bromine, hydrogen, and then I have chlorine. Hope it shows. Yes, it does. Hydrogen. All right. So I have that. And from that, we are going to tilt a little bit. And let's use a different color here. Now, this is this line. And I'm looking at that from, this is my eye. So this line here, you have a metal down. And this side, you have chlorine to your right, say if your view is here. And to the other side, you have a hydrogen. I am gonna make this line bolder. It's not showing too good. Okay. And now you have an OH here, and H, and bromine. And that is a sawhorse, wedge and dash. And now looking at that, this carbon in the front, I'm going to draw the Newman projection. So of that exactly. So the carbon in the front has a metal here, and then I have chlorine, hydrogen. The carbon in the back is this one. Again, this is my view. I'm looking at that here. That's the one in the front. This is in the back. OH is up. And now I have hydrogen and bromine. This is a staggered. It is a Newman conformation, but it is staggered. And from that, I am going to do another, say that a conformation of the same molecule. So this time, again, what I want to do, I'm going to keep the one in the back the same, but now I want to put the chlorine up here, meaning that I'm going to rotate this way, the carbon in the front. And now if I have, see, chlorine, hydrogen, metal in the sequence, following this sequence, chlorine, hydrogen, metal in the back. So that's one. The sequence in which you have the substituents. Again, if you go counterclockwise, as this arrow is, so chlorine, hydrogen, metal attached to the front carbon. And then the one in the back, I said that I was going to leave the same. So it's hydrogen and bromine. That's again another Newman projection, but this is eclipse. And from that, now I can draw my, my Newman. And let's see, I'm gonna have to do it a little small here. I have in the carbon in the top, I have a chlorine, right? So this one is the front. And then I have metal. And I see here hydrogen. The carbon in the back has an OH. Remember that those positions, these two, are the one in the vertical. And then I have to the right-hand side, I have a hydrogen and a bromine. So that's your Fisher projection of that one. And we can actually determine the absolute configurations. We can do it here, we can do it there, in several places. But we're going to practice to remember what was the convention of determining absolute configurations at chiral centers in the Fisher projections. So again, you start like you did always. So which is giving priorities to the group. So that's one chiral center. Priority 1 is the chlorine. Priority 2 is the chain below, because here you have a carbon attached to bromine and oxygen. That is higher priority than having a carbon attached to 3 hydrogens. So for the carbon, let's do a little circle here. For this carbon here, highest priority group is the chlorine. Second highest is the chain going below, and then the metal. In them, I know that my lowest priority, of course, is a hydrogen. If I look at the configuration here directly, you will do 1, 2, 3 like that. But you know you're not viewing this with the lowest priority group away from you. Why? Because hydrogen is in the horizontal line, it means it's on a wedge. If it was here, you can do that directly, but it's on a wedge, so it's not away from your view. So even if you're seeing this rotation like counterclockwise, the configuration of the center is R, so the opposite. You can also do that doing one switch. If you switch this two, if we can do that, let's do it in a separate drawing. I'm just erasing my sawhorse. Let's say that from here, because the hydrogen was not how I want it, so away from my view, I am proposing to make a switch between two groups. So let's say that I switch those, the 4 and the 1. If I do that change, then the new structure will be here. We'll have the chlorine, CH3, and here you will have HOH and bromine. Now, notice the convention. The hydrogen is now, which is the lowest priority away from your view. So that was good. You can do it directly. Highest priority is chlorine. Then the second highest is here. Third is here. So what you do then is remember that you did one switch. And that one switch gives you the opposite configuration. So now you will do priority 3, 1, 2, and 3, and I need to use another color, 1, 2, and 3, right? So it is now, notice, counterclockwise. So it is showing you S, but you got to remember that you did one switch. As drawn, this is S, which means that the original molecule is R. So things that you can do when you do that. And so lastly, let's assign the configuration of the other center below. Highest priority is bromine. Now you are between the chain with carbon and the oxygen, so clearly oxygen is your second priority. 3 is the chain above, and 4 is the hydrogen. And again, you are having the hydrogen on horizontal line, meaning a wedge. So now you're going to do 1, 2, and 3 is above. You're doing it looks like S, and this is the same here. The other center, remember, I didn't change it. 1, 2, and 3 above, and that's 4, so you did 1, 2, and 3. You did S, but remembering that your hydrogen is pointing towards you, you're viewing it that the opposite way. So instead of being S, this is R. And same here, that center, notice, is identical. And you can do many things here. For example, these two are R and SR are diathermers. And there's many more things that we can do, but we will do more videos on this topic.